Oh no. That's something that I totally forgot to do today was open OneNote. I apologize. So let me start sharing my screen. Today is Can you guys hear me?
Yeah.
Yeah, I can hear you.
All right. Somebody sent me a text that they couldn't hear me. So I'm going to reply that it's just them. And okay, today everything's going to go wrong. Today is March 15th. We're going to look at measures of central tendency. Your probability project is due by the end of the day today. And if you give me just a second, today is the 15th. Homework 14 is due today. Homework 15 is due on Wednesday. And we'll look at that again at the end of class. Before we get started with the new content, let's look at does anybody have questions on anything from the homework or the project?
No.
No? Okay. Then what we're going to look at today, it sounds much fancier than it really is. We're going to look at measures of central tendency. And what the measures of central tendency are different measures of the middle of a data set. Different ways of describing the middle. And when we look at those different descriptions of the middle, some people consider them different descriptions of average. And I am going to hope that some of these are familiar to you folks. They are what I consider the 4 M's. And the first M that we're going to look at is the mean. Has anybody in class heard of the mean?
Can you scroll up a little bit again? I'm sorry.
Is that far enough?
Yes.
Okay, great. Has anybody in class heard of the mean of a data set?
Yeah.
What is it? Anybody know offhand? I think the mean is what people usually think of when they talk of average. It's sometimes called the arithmetic. It would help if I could spell right now.
Is that one like the average?
Yeah,
Okay.
average, which means what we do is we take the sum of the data values and divide by the number of values. We sometimes write that symbolically, an X with a line over it. It's sometimes referred to as X bar. And X bar usually means the mean. Usually, we use a lowercase n for the number of data values, which also actually turns out to be our sample size. Sometimes you see this Greek letter, it's an uppercase sigma, and it's used to represent taking the sum. And sometimes we see these subscripted variables. X sub I will mean any data value. And so I might have X1, X2, X3, up to Xn. Those little numbers don't really have anything to do with computation, but rather this is my first value, this is my second, this is my third, up until the last one. And so if I use this notation, I can say that X bar, the mean, is equal to the sum of my data values over the number of values. And so this is just a concise way of writing that the mean is equal to the sum of the data values divided by the number of values. Or it's the average, the way you usually think of finding the average. And so let's go through and let's create a data set to find the mean of. And for the data set, I'd like to ask everybody in class, how many siblings do you have? And by siblings, I mean brothers and or sisters. Don't count yourself, but count how many brothers or sisters you have. I think that we should get a sizable number of folks when we do this. Pam, let's start with you. How many siblings do you have?
I have 4.
Thank you. I'll go next. I have 3. Karina, how many siblings do you have?
I have 2 brothers.
Jaden, how about you?
I have 2 also.
Sienna, how about you?
Technically, I have like 9.
Cool. Matthew, how about you?
I just have 2 sisters.
Okay. Let's see. Michaela, how about you?
I have 4.
Vinny, how about you?
I have 1.
Mackenzie, how about you?
I just have 1.
Marilyn, how about you?
4.
Alan, how about you? Alan? Alan, can you unmute yourself? Okay. Kayla, how about you?
I don't have any.
Let's see. Mackenzie, how about you? Oh, wait, Mackenzie, did we get you already?
Yeah, you got me.
Yeah,
already.
I'm sorry. Bianca, how about you?
Yep.
Oh, I didn't hear that, hon.
I'm sorry, I'm in an airport and I kind of have really bad connection right now.
Okay, then don't worry about it. We won't include you in
Okay,
our.
I'm sorry.
That's okay.
I'm sorry.
Don't apologize. William, how about you?
I have 2 siblings.
Two. Okay, so let's go through and let's find, based on this data set, the mean number of siblings. And so in order to find the mean number of siblings, X bar, it would be the total 4 plus 3 plus 2 plus 2 plus 9 plus 2 plus 4 plus 1 plus 1 plus 4 plus 0 plus 2 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so when we add that up, does anybody have a calculator handy that can do the addition for us?
I got it. I got 34.
34 divided by 12 would give us 2.83333333. Okay. As I look at this answer, did anybody have 2.8333333333 siblings? No. So is everybody all right? One thing we need to make note of is that the mean does not have to be a data value. Another thing, that's a repeating decimal. We weren't that accurate. Our original data, was always whole numbers. So there's a rounding rule that we're going to, if we're not told where to round to, we're going to go one place value to the right of the original data. So what the heck does that mean? Our original data is whole numbers. This would be the whole number. So I'm going to round one place to the right, which would be to the 10th place. So I'll say that our mean is 2.8. Everybody all right with that idea? Just rounding one place more exact than your original data.
Yeah.
Then one thing we have to talk about with respect to the mean is that the mean is, it's called not resistant. It can be changed by extreme values. And so, not to go through and say that anybody's family was an extreme one way or another, let's look at the mean. Let's divide the class in half and look at the mean for two halves. Let's look at the mean of the first half of class, and let's look at the mean of the second half of class. So I have to apologize. I'm going to, after I throw my stylus around, I'm going to go through and take this list. And no, that wasn't a good one. I'm going to go through and take this list and copy it and go down here and paste it and split it in half. 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so for the first half, we'll have the 4 plus the 3 plus the 2 plus the 2 plus the 9 plus the 2 divided by 6. And for the back half, we'll have the 4 plus the 1 plus the 1 plus the 4 plus the 0 plus the 2 and divided by 6. And so for the first half, when we add those, 4 plus 3 plus 2 plus 2 plus 9 plus 2, we get 22 over 6, which would give me rounding rule 3.7. And for the second half, when I take the 4 plus the 1 plus the 1 plus the 4 plus the 0 plus the 2, I get 12 divided by 6, which is 2. And in terms of number of siblings, you see that they're very different answers. One is almost 4, and the other is exactly 2. And while they're both from the same original data set, this first half of the class has a family with 9 siblings, which would be a little bit larger than normal. And the second half has a family with 0 siblings, which would be a little bit smaller than normal. And so do you see how that larger value makes the mean much higher? And over here, that smaller value makes that mean much lower. So that we say that the mean is not resistant. It can be affected by extreme values. It would be like, for example, if I wanted to find the mean age of somebody in class today, I'm guessing that most of you are in your late teens and early 20s. And if we added my age to the group, it would make that average much higher. One extreme value definitely can have an effect on the mean. And we'll find that some of those other measures of central tendency are more resistant. They aren't influenced that much by one high value. Another example that I like to think of is, let's say that there's a neighborhood somewhere out in the country. And let's say that within this one region, let's say within an acre, there is a mobile home park where the average home value is well below $100,000. And then let's say across the street, because there's, a big, beautiful piece of property, somebody built $1 million home. If you were to take the average of all of those $100,000 homes, with that $1 million home, it would make the average price seem much higher when there's really only one home that is of higher value. So can everybody sort of wrap your mind around what it means to be not resistant? A single value can really change the average. One other thing that we have to be able to do with the mean is we have to be able to find the mean from data in a frequency distribution. And so for data in a frequency distribution, let's again take that number of siblings. And if the technology gods are good to me, I should be able to still paste that list in here. Yep. And let's go through and let's take this list and turn it into a frequency distribution. So we'd have a column for the number of siblings. And we'd have a column for the frequency. And so 0 siblings, there was 1. 1 siblings, there were 2. 2 siblings, there was 1, 2, 3, 4. 3 siblings, there was 1. 4 siblings, there were 3. And 9 siblings, there was 1. Let's see. 6, 7, 8. Yep, that adds up to 12. So we included everybody. Well, if I'm going to find the mean from a frequency distribution, I have to, first of all, find the total of the frequency. That's going to be my n. That's going to be my sample size. Now, does it make sense to say that I can't just add up my data values because there are more than one family with 4, there's more than one family with 2, there's more than one family with 1. So what we need to do to account for the fact that there are multiple families is we have to multiply each value by its frequency. Well, if my data values are my x sub I and my frequency would be like my n, then I'm going to take that x sub I times n. I'm going to multiply the data value by its frequency. Put little multiplication symbols in here. So 0 times 1 is 0. 1 times 2 is 2. 2 times 4 is 8. 3 times 1 is 3. 4 times 3 is 12. And 9 times 1 is 9. Then I'm going to total those products. And I apologize, I keep making things larger and smaller today to try to get it all to fit on the same page. And so when I add that 9, 10, 11, 12, 13, 14, 22, 23, 24, I get that 34 that we had when we totaled our values. And so the mean is equal to the total of the products divided by the total of the frequency, which would be our 34 divided by 12, which you think I'd remember what we got for that answer on the preceding page, but I'm going to double check, is my 2.8. And does it make sense if our data is presented in a frequency distribution? We need to do what's considered like a weighted average. We need to multiply each number, each data value by its frequency. And I have to apologize, I don't remember if I included this homework question in the homework or not. So I'd like to look at one more idea that's similar to this idea of finding a mean from a frequency distribution. And it's going to be finding your grade point average. Everybody's familiar with your grade point average, the grade that your average for your college courses.
Yeah.
It's not just a straightforward average of the letter grades that you get, but it's considered a weighted average. You need to multiply each grade by what would be considered the frequency or the number of credit hours. So let's say, for example, that let's say somebody takes a bunch of classes. Let's give them their grade. Let's also put in the number of credit hours in the class. So let's say somebody's taking a math class and, oh, it's math. They're getting an A in it. And let's say it's a 4-hour class. Let's say somebody's taking an English class. Let's say in English they get, I don't know, what grade you want to give this person in English? A B. And that's a 3-hour
Yeah.
class. And let's say somebody's taking a history class. And let's say in that history class they get a C. And that's a 4-hour class. And let's say that somebody's also taking a physical education class and they're like me, they're not real coordinated, so they get a D in it, and that's only 1 credit hour. So that would give somebody 12 hours, which would be considered full-time. An A is considered 4.0, a B is considered 3.0, a C is considered 2.0, and a D is considered 1.0. The number of credit hours is kind of like our frequency column. And so the total number of credit hours that this person is taking is 12. And now what we have to do is we have to multiply the grade times the number of credit hours. The grade would be like our data values, our X sub I. And so when we take the data value and multiply it by its frequency, 4 times 4 would be 16. 3 times 3 would be 9. 2 times 4 would be 8. 1 times 1 would be 1. And we'd add all of that up, which gives us, oh my heavens, does that add to 34 just like our other answer did? And so, wow, we keep doing the same division, right? 34 divided by 12 gave us what, 2.8? And so this would be this person's grade point average.
Did you intend to make it add up to 2.8 in the end?
No, that's why I said, oh my heavens. We were just making up grades as we went. I think that this tells me that today I need to go and buy a lottery ticket or something, because the fact that all of those are adding up to 34 divided by 12 is kind of weird, yeah?
Yeah, it is a little weird.
That was like such a coincidence. I can't believe it. So, but this idea of if it's given to you in a frequency distribution, you multiply the value times the frequency. And I don't know, were you guys aware that that was how they figured out your average? That the grade you get in a 4 credit hour class has a much bigger influence on your average than the grade you get in a 1 credit hour class. So, all right. Are there any questions on finding the mean?
No.
No. Okay. Then the next measure of central tendency is the median. And have many of you heard of the median before? When I hear the word median, I think about when I'm driving. And if there's a median in the street, it means that there's a barrier down the middle of the street. And the fact that in the street, the median's in the middle helps me remember that the median is the middle value in my data set. When I take that middle value in my data set, it's important though that to find the median, I need to order the data first. You're not just going to take a random group of numbers and find the middle. You have to put those numbers in order first. And so if I go back to our example of the number of students in class, the number of siblings, pardon me, that students in class have, if I were to put them in order, first I'd have the 0, then I'd have the 2 1s, then I'd have the 1, 2, 3, 4 2s, the 3, the 3 4s, and the 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then to find the middle, we can count in from the edges, 1, 2, 3, 4, 5, 6. Right now, because there's an even number of values, there's no exact middle. The middle's in between 2 values. So we take the mean of the middle 2. So here our median would be 2 plus 2 divided by 2, or 2. And what's interesting is that the median is resistant. If I look at dividing the class into the 2 halves, the first half being like before, the 4, 3, 2, 2, 9, 2, and the second half being the 4, 1, 1, 4, 0, 2. If I try to find the median of each half, putting the first half in order, 2, 2, 2, 3, 4, 9, the median would be 2 plus 3 over 2, or 2.5. Putting the second in order, 0, 1, 1, 2, 4, 4. The median would be 1 plus 2 over 2, or 1.5. Actually, this almost shows as much as discrepancy as the other. But usually if you're working with a large set of data, the median wouldn't be that involved. Picture that example that we had with all of the $100,000 homes and the $1 million home at the end of the list. The middle would still be that $100,000 home. Or if you picture all of your ages and your mostly teens and 20s, my age in the 60s wouldn't change where the middle is as much as it does with average. If there's an odd number of values, we'll have an exact middle. And we won't have to take the average of those two. So let's say, for example, we looked at, I'm trying to think of a set of numbers that we can use. Let's see. I don't have it in front of me right now. Well, let's just pick. I need 5 people to give me their favorite numbers. Just shout them out to me. First 5 people.
5.
5,
4.
4,
7.
7,
4.
22.
4, 22. Oh, this is a good example because we've got that extreme value. If I were to put them in order, I'd have 4, 4, 5, 7, 22. And so does everybody see here? There is a single number in the middle. And so we'd say that our median is 5. Now, Mr. Blitzer gives us a formula for finding the position of the median, which is kind of a way of finding where the median is in the list. And so if n is our sample size or number of values, the median is at n plus 1 over 2 in the list. What the heck is that all about? Again, part of writing on a touch screen, I lose the ability to count with my fingers, but sometimes people, when they look to find the median of the list, they start at both ends and they count in until they get to the middle, which is fine if we've got a list of 5 numbers or 12 numbers. But if I had a list of 500 numbers, I wouldn't want to be counting in from the middle to find it. So if n is the sample size, let's go look at this example. If I wanted to find the position of the median, here n is 5. There are 5 numbers in the list. So 5 plus 1 divided by 2 would be 6 divided by 2. And we got that the median was the 3rd number in the list. If I go up to the preceding example, here, if I wanted to find for the whole class the median, the position of the median, well, we had 12 numbers plus 1 over 2 gives me 6.5. And so it's halfway between the 6th and 7th values. And so we can use that position of the median to help us find it. Instead, if we want to find the median from a frequency distribution, can I turn the page and not lose anybody?
I'm a little lost
Go ahead.
how we got the 6.5 on there.
Oh, I apologize.
Okay.
Give me a minute. I did some arithmetic in my head. Let me erase.
Thank you.
There were 12 numbers in the list. 12 plus 1 divided by 2 would be 13 over 2, would be 6.5. Better?
Yes.
And so now, if we want to find the median from a frequency distribution, let's see if I can remember the frequency distribution that we had before. Number of siblings was 0, 1, 2, 3, 4, 9. Frequency, I believe it was 1, 2. Oh dear, I can't remember. I have to go back a minute. 1, 2, 4, 1, 3, 1. 4, 1, 3, 1, and this added up to 12. If I have a frequency distribution, I have two options. One is to make a column that's called cumulative frequency. Which is the total of the frequencies so far. So over here, there's only one value. Now, when I add 2 more, I get 3. When I add 4 more, I get 7. When I add 1 more, I get 8. When I add the 3 more, I get 11. And lastly, when I add that last one, I get 12. We're going to say that the median is in the first class where the cumulative frequency is greater than or equal to the position of the median. And so we had said that because the number was 12, the position of the median was 6.5. And since 7 is the first one greater than 6.5, the median is 2. That's the way I like to do it. I also know that students don't like that at all. And so the other way of doing it is to just recreate the data value. And so from this table, if I were to recreate the data set, I have 1, 0. I have 2 1s. I have 4 2s. I have 1 3. I have 3 4s. And I have a 9. And then I can find the median from there. And the homework, I think more students like to use this idea of recreating our original list of values than doing the cumulative frequency thing. But picture if I had a table that represented 1,000 values. I don't think I'd want to recreate that list. So, and I'm looking at the time and remembering that we didn't take attendance yet because the attendance function wasn't working on my Chromebook. I do have it working, but before I go ahead and take attendance, I'm looking at the beginning of class, this homework that's due on Wednesday, because we didn't get through all of the measures of central tendency, I'm going to push that back to Friday. So as soon as we're done with class, I'm going to change the due date on that assignment. Let me go through and let me stop sharing. Pam, you're here.
Yes, I am.
You're here. Karina, you're with us. Bianca? No. Alan?
Yes.
Okay. Marilyn, you're here.
Yes, I'm here.
William, we let you in. You're here. Sienna, you're here. Matthew, you're here.
Yeah, I'm here.
Michaela, we gotcha. Mackenzie, gotcha. Thank you. Kayla, gotcha. Jaden, thank you for being here. Thank everybody for being here. And Timothy, we don't have. I apologize for the couple of technical problems, but mean and median, is everybody comfortable with those two? Next class, we'll look at the mode and mid-range, and then we'll start looking at the standard deviation. So have a great day, you guys.
You too. See you Wednesday.
We'll see you Wednesday. Bye-bye.
I'm not sure. I was
Sorry
thinking
about
about
earlier. Oh, go ahead.
Go ahead.
I always said sorry about earlier. My internet dropped, so I had to rejoin the chat.
Oh, that's beyond your control. And you know what's really embarrassing? It's really embarrassing when that happens to me when I'm the teacher. So don't feel like you need to apologize for that. All right.
All right. I just want to make sure I'm good with attendance.
Oh,
That's all.
you are. You are. We got you. Okay.
All right. Thank you.
Have a
good
great one. Bye-bye.